And here we go with our review of for test 4. This is the review of the chapter about hypothesis testing, that's chapter 8 and chapter 9, and correlation and regression, chapter 10. Question 1. A manufacturer states that the average lifetime of its television sets is more than 84 months. A sample of 20 sets is observed, and the average lifetime for this sample is 88.1 months. The population standard deviation is known to be 7 months. At alpha equals 0.05, what does this say about the manufacturer's claim that the average lifetime of its sets is more than 84 months? So the claim that we're testing here, that we're doing our hypothesis testing procedure on, is that the average is more than 84. So we can write that like this: mu is greater than 84. So we're testing a claim about mu, about a mean. Now, are we doing a z-test, like we talked about in section 8.2, or are we doing a t-test, like we talked about in section 8.3? Well, what makes the difference? The difference is based on the standard deviation. Do we know the population standard deviation or just the standard deviation for the sample? Well, here we're told that the population standard deviation, that would be sigma, is 7 months. So when we know sigma, we can do a z-test. So this is a z-test for a mean. Now let's work through the steps of the hypothesis testing procedure. Step 1, state the hypotheses and identify the claim. So we said that the claim was that mu is greater than 84. And that would be the alternative hypothesis. Because it doesn't have an equal sign, it has a greater than sign. So if we write that with an equal sign, mu equals 84, that's going to be our null hypothesis. So we know what our null hypothesis is. We know what our alternative hypothesis is. They look the same except that the null hypothesis always has an equal sign, and then the alternative hypothesis has one of those not equal signs, in this case a greater than sign. And it's the alternative hypothesis that is the claim. Now, step 2, we're going to compute the test value, and to do that, in this kind of a test, we need 4 numerical values. We need the number that we are comparing mu to in the claim and in the null and alternative hypotheses. So remember that the null hypothesis was that mu equals 84. So that's the number that we'll be using for mu or mu sub 0. We need to know sigma, that's the population standard deviation, and we're told that that is 7. We need to know x bar, that is the sample mean. So a sample of 20 sets is observed, and the average lifetime for this sample is 88.1. So usually your sample mean x bar is going to be fairly close, but not exactly the same as your mu number. And then n is the sample size. It's how many TVs there are in the sample. So that would be 20. Now at this point, we've seen a few different ways that we can go with these numbers. If you have a graphing calculator, you can go to the z-test function and just put in these numbers. If you're working with that Excel spreadsheet, you can go to the z-test tab and put in those numbers there. If you want to calculate it using the formula, z equals x bar minus mu over sigma divided by the square root of n, you can do that. So I'm not going to show you how to do this because there's different ways of doing it. Pick the one that works best for you or you're most comfortable with. But whatever you do, you should come up with z equals 2.62. Actually, it's not going to be exactly 2.62, but if you round it to the nearest hundredth, to 2 places after the decimal point, that's what it is. And then step 3 is to give the p-value. And if you use the graphing calculator or the Excel spreadsheet or something like that, when it told you the z, it should have also given you the p-value of about 0.0044. If you're doing this yourself, if you calculated the z-value from the formula, you're going to want to look the p-value up on the table. Now, step 4, make the decision to reject or not reject the null hypothesis. And that's based on comparing the p-value, which we just looked at, to the level of significance alpha, which is 0.05. The smaller the p-value, the less likely the null hypothesis is to be true. So it's not exactly accurate to say that the p-value is the probability of the null hypothesis being true, but you can kind of think in those terms. It's actually the probability that you would get these kind of results if the null hypothesis were true. But a small p-value means the null hypothesis is probably not true. We're going to reject it. So in this case, the p-value was small. It was smaller than the number we were using for alpha. 0.0044 is less than 0.05. So we reject the null hypothesis. So remember, in step 4, you're always going to be saying one of two things. You're either going to say reject the null hypothesis, which is what we said here, or you're going to say do not reject the null hypothesis, which is what you would say if you had a p-value that was greater than alpha. So it's always either reject the null hypothesis or do not reject the null hypothesis. Now, step 5, summarize the results. We rejected the null hypothesis. Remember, that's what we just said. The claim, if you look back up at step 1, the claim that we were testing was the alternative hypothesis, that mu was greater than 84. So rejecting the null means supporting the alternative. So if we rejected the null hypothesis, there was enough evidence to support the claim. So I would summarize my results like this. There is enough evidence to support the claim that the average lifetime is more than 84 months. Okay, let's go on and do another one of these. Number 2, a wizard tells a princess that the average length of a unicorn's horn is 14 inches. To test this claim, the princess finds a sample of 10 unicorns and measures their horns. The mean length of the horns in her sample is 13.1 inches, with a standard deviation of 1.8 inches. At alpha equals 0.01, what can she conclude about the wizard's claim that the mean length is 14 inches? So the wizard said mean length is 14. Princess measured some actual unicorn horns, got an average that was different, at least a little bit different from 14. Was that enough of a difference to make her think that the wizard was wrong about the average being 14? So that's the claim we're testing, that the mean is 14, that mu is equal to 14. And we don't know the standard deviation of the population, but we know the standard deviation of the sample. The mean length of the horns in her sample was 13.1 inches with a standard deviation of that sample of 1.8 inches. So since we only know the standard deviation of the sample, we would be doing a t-test for a mean. Okay, let's work through those same 5 steps. Step 1, the claim is that mu is equal to 14. And I apologize, I had to go in and fix that. The Claim is the null hypothesis because it's got an equal sign in it. The alternative hypothesis would be what's true if the null is not true, that mu is not 14. So it either is 14 or it's not. The wizard is either correct that it's 14 or the wizard is incorrect. It's something different from 14. Step 2, compute the test value. So the number in the hypotheses is 14. That's what we're comparing mu to. That's what the wizard says that mu is. S, the standard deviation of the sample, is 1.8. X bar, the sample mean, so that would be the average length of the unicorns in the sample, is 13.1. And N, the sample size, how many unicorns were in the sample, that's 10. Then using these numbers and the method of your choice, we come up with a test value of t equals negative 1.58. And then the p-value turns out to be 0.1483. And that p-value is greater than the level of significance. 0.1483 is greater than 0.01. So we do not reject the null hypothesis. Step 4 is always either reject or do not reject the null hypothesis. It's always about the null hypothesis. It's always about whether or not we reject it. Here we do not reject it. So there was not enough evidence to what? Well, we did not reject the null hypothesis, and that was the claim. The claim was that the mean was 14. That was the null hypothesis. We just said we could not reject that. So there is not enough evidence to reject the claim that the mean length is 14 inches. In other words, the wizard could very well be right that that's the average length of all unicorns' horns. The princess got a sample mean that was a bit different from that, but it wasn't enough different from just that sample of 10 unicorns to make her really doubt that the wizard was wrong in all. So it could still be true that for all the unicorns in the whole world, in the whole enchanted forest, the average length is 14 inches. Okay, I'm going to end this video here. It's a nice stopping place, and come back in the next one and work through some more of these example hypothesis testing problems.